Well, good morning and welcome to the launch event for the Cyber Physical Infrastructure Vision. After 18 months of ideation and consultation, the Cyber Physical Infrastructure Vision document is now released this morning, and you can obtain it from the UK Robotics Growth Partnership website, and that's at ukrgp.org. And I would encourage you to obtain a copy and study this important document. It's some good reading for the weekend. Studying the Cyber Physical Infrastructure Vision document will enable you to contribute your thoughts, your views, opinions, hopes, fears, ambitions to the government's national consultation, which will take place about the cyber physical infrastructure. And this consultation was announced in the UK National AI Strategy document, and it's an essential component to the delivery of the AI strategy as we look to the future. In July 2021, a summit was organised to explore various issues around the need for cyber physical infrastructure. And this was supported by the Royal Academy of Engineering, the government's Department for Business, Energy and Industrial Strategy, UKRI, GoScience, the Alan Turing Institute, the UK Robotics Growth Partnership, and the Centre for Digital Built Britain. There was in excess of 450 participants from a broad and representative range of stakeholders, and that's informed the development of the Cyber Physical Infrastructure Vision document that's being announced today. Now, the only piece of housekeeping to mention to you is if you would use the chat for discussions and observations and comments, but any questions that you might want to pose, if you would put those into the Q&A tab. Now, without any further ado, let's hear from the UK Government Minister for Science, Research and Innovation, George Freeman, and he will then be followed by a short video animation and a presentation by the co-chairs of the UK Robotics Growth Partnership, Paul Clark and David Lane.
I'm absolutely delighted to be here today joining this really exciting launch of the Cyber Physical Infrastructure Vision document and the start of our deep conversation with the sector about where we want to go next. Thank you to the Robotics Growth Partnership and the Centre for Digital Built Britain for hosting this. I'm really honoured to be the Minister for this sector, and I want to start by congratulating David Lane and Paul Clark and the rest of the RGP on their really exciting vision for this national capability in CPI, including, of course, robotics and smart machines, where it all started. As Minister for Science, Research and Innovation, my job is to make sure that we take this historic opportunity of developing a new economic model in which the UK puts science, technology and innovation at the heart of our economy. And that's really about both deep science leadership, becoming more of a global science superpower, and growing our capacity as an innovation nation, making sure we attract the capital to build companies, develop clusters all around the country. And the CPI piece sits right at the heart of that more strategic international approach to science and technology. The integrated review set out our ambitions to be more strategic about national resilience and harnessing science and technology for UK leadership in the digital infrastructures of tomorrow. And in our R&D strategy, our roadmap, the innovation strategy, we've set out a commitment to support the technologies of tomorrow, to drive the sectors and the clusters of tomorrow, to create the jobs of tomorrow all around the country. And specifically in there, we highlighted smart machines, robotics, AI, digital and advanced computing. So this is a major strategic area of interest for us. And as well as public sector investment, strong industrial investment, both from major players, but also from new companies that haven't even yet been brought into existence yet, to seed and support the creation of a vibrant ecosystem of SMEs and investors. And today's publication from the RGP highlights how we envisage having and developing a national capability in cyber physical infrastructure is a key part of both our national resilience and our innovation economy. You know better than me that cyber physical infrastructure is already beginning to have transformational impacts, whether it's in net zero or in life sciences, drug discovery, to some of the work that we're doing on space, autonomous vehicles. In so much of the interdisciplinary sector, it is this interaction of smart digital infrastructure that is driving innovations. And it's going to be crucial for us in government to make sure that we are making the right choices, that we're understanding properly where the UK is strong, rather than where we think we're strong, where international finance and funding is flowing, and what the real opportunity is for us. So I'm hugely grateful for the very extensive engagement that we've had, the RGP has had from all of you, including that very well attended Cyber Physical Fabric Summit last summer. And it's why I'm really pleased that we will, in government, shortly be building on this by launching our own formal consultation on what our UK capability in digital twinning and CPI should be, informed by the RGP's vision. And we'll be looking internationally as well as here in the UK for insights on what we should be doing. That consultation has three broad aims. Firstly, to broaden the conversation, the UK industry, academia and public sector understanding of the impact and opportunities of digital infrastructure and cyber physical systems. Secondly, and crucially, to explore the potential industrial and commercial opportunity for growing UK leadership in this space and to grow a strong cluster here in the UK. And thirdly, understanding where CPI can help drive broader innovation in our economy. I'm really looking forward to your feedback, and I hope you will all take the opportunity to read today's publication and to take part in the consultation once it's launched. This isn't a tick box consultation. We don't know the answer already. We need to hear from you in order for us to make informed choices that over the next few years you can look back and say that helped to grow a really vibrant sector. So whether it's in deep tech, we want to hear from you where we should be investing. This phenomenal increase in UK public R&D investment, the biggest for a generation, 30% increase. We're going to 20 billion a year over the next 3 years. Or at the other end, nearer market, to hear from you where we can make big steps in terms of our new regulatory freedoms outside the EU, setting the standards, helping to attract finance, scale up skills. So whether it's deep tech or near market, we're keen to hear your thoughts. Thank you again to the RGP for putting this together. It's a really exciting moment, and I'm keen to hear from you, the people in the sector, where we can help you. This is a private-public partnership. If we get it right, we'll look back in 5 and 10 years and see phenomenal growth. That's the ambition. You achieve it. Thanks for all you do, and I look forward to your comments and your feedback today and from the government consultation to follow soon.
Our material economy is built on combining experience, intelligence, and physical action. Over the last 100 years, we have made machines work better for us. In the beginning, these machines worked in isolation, processing materials or information. Communication has now connected them together. The next step is cyber-physical services that connect data and knowledge with physical action. These cyber-physical services are built on digital twins that capture real-time data, human experience, use AI to manage complexity, and robots to deliver physical interactions. Together they weave a cyber-physical fabric that interacts with us and the world around us and does so with knowledge. We have the threads, but haven't yet made it easy to weave them together. By building and sharing digital and physical resources, we can create the cyber-physical fabric that makes it easy for everyone to build connected smart machines. The fabric is a connected ecosystem for innovation and collaboration. It enables anyone to go from the idea of a cyber-physical service to virtual testing before trying the solution in a physical testbed and a living lab. The fabric is a new material from which we can fashion all manner of new products and services.
Good morning, everybody, and thank you very much again for attending this event. to launch the vision for a national cyber-physical infrastructure. Thank you, Minister Freeman, for your very supportive opening remarks. We're all very grateful to Mark Jolony for comparing this event, and for the Centre for Digital Built Britain and the Digital Twin Hub for hosting it. My name is Paul Clark, and along with Professor Emeritus David Lane, we co-chair the Robotics Growth Partnership, or RGP. This vision represents 18 months of public and private workshopping, networking, discussion, and authoring by members of the RGP, with strong support from BEIS, UKRI, the AI Council, and other stakeholders. It also builds upon the highly successful Cyber-Physical Fabric Summit that we ran in July 2021, which attracted over 450 attendees and established a coalition of the willing across academia, industry, and the public sector. David and I would like to thank the members of the RGP and everyone else who has contributed to this vision, but especially Bill Murray, Alexandra Bolton, Mark Enzer, and Dame Wendy Hall, who have supported us throughout this journey. David, over to you.
Thank you, Paul. I'd like to second those thanks. This has been a team effort for sure. And good morning, everybody. My name is David Lane, co-chair of the RGP, and it's a great pleasure to be in a position this morning to finally launch our recent collective thinking. We hope some of you have had the chance to read the cyber-physical infrastructure vision that is now available on the .gov website and posted into the chat. For those of you who haven't had a chance to read it, Paul and I will now try to sum up the conclusions of 18 months of work in under 15 minutes. Following the pandemic, the UK and indeed the world faces the prospects of further exogenous shocks and threats to our existence. Here are some you might like to worry about. Volcanic eruptions, solar activity, economic crash, cyber terrorism, climate emergency, resource consumption, earthquake, conflicts, and more I'm sure you can think of. The next exogenous shock is not usually that which we planned for after the last one. We learned from the pandemic that the nations who had equipped themselves with the best tools rather than the best plans were best able to respond and demonstrate some resilience. From supply chain management to healthcare outcomes, they had the means to be agile and to adapt. Paul, if you could move the slide on. The tools that we build to support our resilience will also help our prosperity, sustainability, and security needs. With the right infrastructure, we can reduce hospital waiting lists, improve lifelong learning outcomes, turbocharge our innovation ecosystem, move towards net zero and sustainable development goals, and secure our supplies of food and energy. Paul.
The UK punches above its weight, but we're competing with other countries with more data, more resources, more money, and sometimes political advantages too. So as a nation, we need to create leverage and defensible competitive advantage by equipping ourselves with those tools, infrastructure, and recipes that will enable us to work smarter, faster, with less risk and at lower cost. Big vertical initiatives and missions lack the time, the budget, the capabilities, and often the vision to build this enabling cyber-physical infrastructure for themselves, let alone to support other initiatives. Companies like Ocado, Rolls-Royce, Arup, and Mott MacDonald are successful demonstrators of the transformative power of this cyber-physical infrastructure, but they are the exceptions that we now need to make the norm. David.
What is the cyber-physical infrastructure? I'm sure you're asking yourself that question. The cyber-physical infrastructure, or CPI as we call it, is a coming wave of networked virtual and physical tools that are as accessible as the web. It fundamentally changes how and where we develop and use sensors, machines, systems, applications, and infrastructure. It enables us to seamlessly function simultaneously in both the virtual and real worlds as we ideate, design, develop, test, adapt, certify, deploy, repurpose, interact with, and maintain every different kind of sensor or machine anywhere. Virtual models and physical components are not monolithically constructed. They are federated over networks in the virtual world and as modular units in the physical world. This brings flexibility to reconfigure and repurpose at pace. Whereas in the web, we use text string search to find information, in the CPI, we use query to ask questions in semantics, to reason over the network and find answers. So machines and people working together in the CPI are systems in an ecosystem who provide smart services to others and so realize economic, environmental, and societal benefits. Just like cooking a good meal, to build the CPI, we need both ingredients and recipes to use them. The next slide that Paul's going to move to shows these major ingredients. For the physical part, we need connected smart machines or robots that can operate in living labs, which themselves can be connected. In the process of moving from research prototypes to real-world systems, this is where de-risking in realistic environments takes place, including the social aspects of working with people. Cyber-physical campuses are networked learning environments where remote and in-person learning can take place using a variety of interaction devices and methods. For the cyber part, shared synthetic environments enable realistic simulation, emulation, and visualization of physical systems, federated using a digital commons of standardized middleware. Once these synthetic environments are connected to their physical counterparts, we create federated digital twins, or shadows, depending whether the outcome of the simulation is fed back to the physical process. Semantic maps are geospatial or more abstract knowledge maps that are fed in real time from controlled and secure crowdsourced data sources. They provide real-time nowcast, forecast, and hindcast of an operational situation. AI uses both cyber and physical ingredients to obtain the crucial training data to make machine learning unbiased and transparent. These ingredients are underpinned by shared data standards for network services, the digital commons for federation, and modular cyber physical building blocks to assemble synthetic and physical systems. Paul.
So David's just talked about some of those cyber physical ingredients, but as he said, we also need new recipes to catalyze innovation, resilience, and sustainability. These different ways of thinking, working, and collaborating are embodied within a family of solutions patterns. Systems thinking, seeing the world as the complex web of interconnected systems and ecosystems that it is, and the role that data, modeling, and AI can play in helping to unravel this complexity. Ecosystem thinking, just as living things depend on ecosystems, the evolution of those cyber-physical ingredients relies on ecosystems that include things like research, technologies, components, services, and competencies. Ecosystems that require investment and nurturing in their own right. Socio-technical thinking. Social science is a vitally important ingredient in the cyber-physical cauldron, but is often overlooked. We need privacy, security, ethics, and trust baked in by design, and we need people involved across the innovation lifecycle, including within those living labs. Agility. As David said, to build resilience to uncertain futures, you need agility powered by better tools rather than better plans. Peter Drucker was right when he said culture eats strategy for breakfast, but I would assert that agility eats planning for lunch. Federation. Instead of building monolithic solutions, we need to harness the power of the crowd by connecting or federating many smaller components, whether they be AI models, digital twins, or swarms of smart machines. Modularity. We need pre-competitive shared building blocks to drive greater standardization and reuse into how we construct complex AI models, digital twins, and smart machines faster, cheaper, and with greater extensibility. Platforms and services, smart services. We're on an evolutionary journey from own to rent to share to everything as a service. Smart platforms and services powered by AI and digital twins can drive orchestration, optimization, network effects, and business model transformation. And last but not least, cyber-physical thinking. We often focus on our digital and physical worlds separately, rather than as a cyber-physical ecosystem. However, where our digital and physical worlds collide, live magical beasts such as digital twins, smart machines, and living labs. And it is at this cyber-physical intersection that the really exciting things happen. Just as Tim Berners-Lee would have struggled to predict all the future impacts of the World Wide Web, we cannot possibly do that for this cyber-physical infrastructure, which we believe could be as equally transformative. But here are a few examples to whet your appetite. Researchers, inventors, and innovators across multiple industries accessing immersive virtual environments to ideate, design, and test new products and services. Virtual environments providing immersive collaborative learning for formal education, reskilling, and lifelong learning with scalable leveled up access by anyone from anywhere. A UK whose infrastructure, public services, and industries are using cyber-physical services to optimize their agility, productivity, resilience, and sustainability, using our country as a national scale living lab to innovate solutions not only for ourselves, but for export. AI, digital twins, and smart machines transforming the quality, scalability, and sustainability of healthcare provision, both across the NHS and within patients' homes. Building digital twins of our food system, both to improve the efficiency and sustainability of conventional agriculture and to explore new forms of sustainable agriculture to turn photons into calories and proteins. Swarms of clean energy powered smart machines on and under the land, on and under the water, in the air and even in space, transforming how we move people and goods around our planet in more efficient, scalable and sustainable ways. New forms of immersive entertainment, transporting us to new virtual worlds we could never visit. Harnessing cryptocurrencies and non-fungible tokens within distributed blockchain implementations to massively reduce the friction in transacting the value of assets and services, enabling ubiquitous and international access. Harnessing data, AIs, and digital twins to increase our understanding of our natural world, to reduce the impact of man-made systems upon it, and to nudge the behaviors of citizens at a planetary scale. But also orchestrating swarms of clean energy powered smart machines to help monitor, clean up, replant, and repair our planet. David.
Thank you, Paul. So why the UK, why government, and why now? We believe this infrastructure could be an accelerant in the delivery of many of the UK's future policies, strategies, and ambitions, including levelling up and becoming a science superpower. Venture capital has created much of our modern world of today. By using its convening power and investment in research and innovation, the UK government can deliver the foundational elements, including the architecture and standards required to bake in interoperability, security, privacy, ethics, and trust by design. The aim is to stimulate crowdsourced innovation and the ecosystem of seed venture investment that leads to adoption by both the private and public sectors. The UK has the opportunity to take the lead in developing this infrastructure for its own needs, whilst at the same time establishing international standards that could support collaborative innovation with other nations on planetary scale challenges. As an advisory group, the RGP is not really in a position to make recommendations on policies or specific instruments that government should use to kickstart the CPI. However, we do believe there are certain delivery principles that are fundamental to achieving the successful outcome of this thriving new ecosystem. The 10 points are laid out here and in the vision document published today. Amongst them, we would highlight this is an agile development endeavour that involves the whole community. Co-creation of the CPI ingredients and recipes into minimum viable product prototypes that address national challenges with outcomes that matter to the public is key. There are parallels with the development of the ARPANET into the internet and the World Wide Web, and indeed the way open source has fueled the development of cloud computing. And there are challenges in governance and security to ensure the infrastructure we construct is both safe and available, achieving the same democratizing and levelling up ambitions of the early internet pioneers. We encourage the UK government, its funding agencies, and our communities of practice to consider these 10 points and the ways they can be put into practice to bring the CPI into existence. Paul.
So hopefully that's given you a taste, and it is just a taste, of the cyber physical infrastructure vision, and please do follow the links in the chat to read the full publication. We are delighted that as the next step on this exciting cyber physical infrastructure journey, as Minister Freeman said, the government is about to kick off a formal consultation process, and we would strongly encourage all of you to get involved in that process and to join us on this journey. David.
If you have thoughts or suggestions on what you have heard, please post them into the chat, and some of you are doing that already, which is great. And if you have questions, please post them into the Q&A for later on. Equally, do get in touch with any of the RGP members if you have ideas or comments about what we are proposing. We also want to hear what you have to say and what you think and what you can contribute. Now we're going to hear the perspectives of 4 key stakeholders who have accompanied us on the journey of the last 2 years and helped us to co-create some of the ideas, applications and approach of the CPI vision. Back to you, Mark.
Well, thank you very much, Paul and David. This is extremely important, and I think that we now have a little bit of time to get some short responses from some of the key people that have been involved in this development. And so I'd like to ask the Chief Executive Officer of Innovate UK, Indra Mukherjee, to provide a short response to your presentation. Indra.
Thank you, Mark, and I'm really pleased to be here for the chance to give and share this short response. You know, since starting with Innovate UK, I've had the chance to get to know the work done by Paul, David and their teams, and that includes Innovate UK people as well. They've worked smartly, collaboratively across many groups to create this vision, and I'm really pleased to support on behalf of Innovate UK. I think we're looking at something that has the potential to be globally transformational. CPI could be an accelerant for innovation, and industry adoption could help make the UK reach global levels and even become a global leader in many of these areas. As the UK's innovation agency, we work to inspire, involve and invest in innovation and commercialization to support business. We see this as a chance for a fantastic public-private partnership with a focus on ethics, respect for people and societal issues and building trust. So we think the team has thought through things very, very well, and we wish them and all the collaborators well as they go forward in the future. Thank you.
Indra, thank you. Thank you very much, Indra. Let me now ask the Executive Chair of the Engineering and Physical Sciences Research Council, Dame Lynn Gladden, for a response to the CPI vision.
Thanks very much, Mark. So let me start by thanking all those of you who have helped drive forward this agenda over the past couple of years. It's really important. And EPSRC, as I hope you all realise, is very much behind this. And I really do believe that CPI will enable the UK to work smarter, faster, more collaboratively, with less risk at lower costs and with greater competitive advantage, as you guys stated in your letter to Minister Freeman. I would also very much like to echo what Paul said in saying that in taking CPI forward, we need to build the shared foundations to bake in interoperability, security, privacy, ethics and trust by design. I think that's hugely important. I also see us building on strengths. I see it as a natural and important evolution of the existing UK capability and research and innovation expertise across AI, simulation and modelling, digital twins, cyber-physical interaction, sensors, and of course, robotics and autonomous systems. I would like to say that I completely endorse and support the delivery principles that have been highlighted, that were put up on the screen earlier, and I think we all have copies of. I think in particular there, I would pull out, for me, the importance of actually getting started in some exemplar studies addressing national challenges, creating national focal points for CPI development. I think including societal and community engagement during that development, and I see a lot of support for that in the chat that's going through. And we at EPSRC really feel that is hugely important in getting the right product out. Embedding and testing security and privacy in the CPI from the beginning. It's not an afterthought, it has to go in early. And I think in parallel with getting things started addressing national challenges, which with tools that we already have, and learning as we do that, actually building on that basic and applied research capability, because these are very fast moving areas, the areas of AI, digital twins, robotics, autonomous systems. So let's make sure that we develop the next generation capabilities that make us competitive and leading where we wish to be. So thank you very much, and I look forward to the discussion.
Lynn, thank you for your comments. And now I'd like to ask Mark Enzer, the Chief Technology Officer of Mott MacDonald and the lead of the National Digital Twin Programme, to provide some comments. Mark.
Thanks, Mark. It's fantastic to be able to offer some comments on this. And I really welcome this vision for cyber-physical infrastructure, really because it provides such a coherent picture. It shows how all the elements of CPI fit together with a common purpose. And I think this idea of kind of integrating technology for a purpose of better outcomes for people, society and nature is incredibly inspiring. But having this vision, having a coherent picture shows how it fits together and how it can therefore be achievable. And I think fundamentally it's about connections. It's really good to see how federated digital twins are seen as a core component of cyber-physical infrastructure. And on the National Digital Twin Programme, we've been working to advance this agenda. And I guess the point I would want to make on that is that the cyber-physical infrastructure isn't something that is just kind of out there in the future. It's happening now. It's real, it's happening now, and we are demonstrating how these connections can provide value, including with our Credo, a demonstrator of using this kind of idea for making better decisions for climate resilience. So it's happening now, which makes all of this achievable. And so I really look forward to the formal consultation, which will help us to take those next steps to make this a reality that delivers real value. And I feel that this vision provides a huge step towards that. And so I commend it to all of us.
Thank you, Mark, for your thoughtful reflections. Finally, we have a video from Dame Wendy Hall from the University of Southampton, who sadly is unable to join us this morning, but we have a video of her comment.
Hello, everybody. I'm really sorry I can't actually be with you live today, but you've got a pre-recording of me, which is just as good, and I'll make sure I keep to time. I just want to give my support to the document and the vision, the cyber physical infrastructure vision, because I think it's so important for the UK that we take a leadership role. I'll come back to that in a minute. I'm sure many of you know that I was responsible for co-authoring the original AI review in 2017, and then with Paul and David and others on the AI Council, and we launched a new strategy last year, and both of those documents referenced digital twins, and the new national AI strategy takes a strong stance on digital twins and the possibility of a national digital twin project and the development of twins. And I'm so, you know, as the document says, digital twins are in ascendancy, and at the moment they had been different things to different people. They're being built in different ways, and the key thing for me is the standards that we can develop for data interoperability, so that one digital twin can talk to another, and we can create this connected digital twin ecosystem, which will lead us to a national digital twin. And if we can get that right, that really puts the UK in a leadership position. And of course, it is, you know, it is just the first step towards the vision outlined in this document, which is the cyber physical infrastructure vision, because it will not be all digital. In this world we're going into, it will be a mix of exactly what it says on the tin, the cyber and the physical. And I see the metaverse coming down the pipe, which both excites me and horrifies me at the same time. And because we don't know exactly how the technology is going to evolve, and we don't know what people, whether it's companies or individuals or the big social networks, we don't know how that's going to play out. We can't really predict what's going to happen, but we can predict that there will be a cyber physical infrastructure that we will need to model, and we will need to make sure works for people and for the good of society in so many different ways, in terms of health and net zero and all the big grand challenges that we have dealing with the next pandemic. You know, it's all going to be about machines and people working together, and getting those interoperability standards for me is the data standards is so important. And again, as there's a section in the document on the role of government, and government shouldn't be, it should be helping create this market. That's what we need to do, so that people know where to go and who to talk to in order to be part of this exciting project going forwards. So we need the government to lead us, but not in a way that says it's all about government. It's actually all about us building the system going forward in a big collaboration, and that's what I'm very excited about. And if this has helped launch that, then I'm happy.
So thank you, Wendy. Thank you, Mark, Indro, and Lynn. What I'd like to do now is invite Paul and David to come and join me for a fireside chat. Unfortunately, there is no fire, and there is no port or whiskey to prime the discussion. But I think there's plenty of things that we need to be chatting about for the next 10 minutes. So let me start off by a question, and to both Paul and David. I mean, organizations, surely they must be already using these technologies. So why does this really require a national initiative to build this infrastructure that you speak of?
Perhaps I can dive in there first. I mean, I think the challenge is, or there are multiple challenges. I mean, the first thing is that, you know, most companies lack everything from the sense of the possible of what these technologies could do to transform their businesses, but also things like the solution templates, the worked examples, the case studies to help embark on that journey. And the barriers to access and adoption are just too high at the moment. As we said in the presentation, you know, some companies are making use of this, and indeed, you know, I used to be CTO of one who transformed itself using this infrastructure. But we in order to reduce those barriers, we need these kind of pre-competitive building blocks across both the cyber and the physical. We need those shared standards. We need the mechanisms for sharing the incremental solutions more effectively, so that everybody's not starting from scratch. And indeed, many companies, because of those high barriers, they lack the skills to build these kinds of solutions themselves, or even to integrate, you know, solutions that they could perhaps buy off the shelf. And that's why, you know, we were saying earlier that the most important starting point is to build these kind of foundational elements, such as the standards, the building blocks, the services, the tools, the infrastructure, and middleware. And we see that as, you know, being something that, you know, government needs to hopefully sponsor and get behind. But once that foundation is there, then, as David was saying, you know, we can crowdsource in the innovation and collaboration and contributions from both industry and indeed the public sector as a kind of a first customer for many of these things, because let's face it, our public sector, our public services need this kind of transformative capability.
I think I would just add to that. Asking that question, Mark, is a bit like asking at the beginning of the internet and the web, why do I need the internet when I've got an ISD, I've got a dial-up line where I can call somebody, or, you know, why do I need the web when I've got everything I need on my own computer? The key point is about network and network effects. And if everybody has the same tools and the same access to tools, we get the gearing. And we've seen that over the years, actually with British inventions like the telegraph, and indeed the railway system, and many others as well. So before the internet and the web. So this isn't the first time we've had this kind of revolution, and it's that network effect, common tools, that gives everybody the gearing and the leverage that we need.
Yes, why do we need a motorized vehicle when we've got good horse stock at our disposal? Now, one of the other interesting things that's coming out of this, and it's already been mentioned in the chat, is the enormous strategic and long-term investments and sustained investments that are being proposed by the hyperscalers in building, creating and delivering their visions for the metaverse. And so how can the UK as a nation really hope to compete in building and delivering and exploiting this cyber-physical infrastructure?
I'll go first, if you like. There are differences between the metaverse and cyber-physical infrastructure, and there are commonalities. The commonalities are things like synthetic environments, the devices that we use to interact as people with these synthetic environments. But there are also big differences, the way that we're doing federation, for example, and the links to the physical world, and the way that we're trying to build infrastructure in a way that's kind of common and shared across different communities. So it's not just owned by, well, we hope it's not going to end up owned by, you know, an oligopoly of key players, but it's going to be something more democratic. And this is one of the reasons why it's important that government kickstarts the infrastructure part, so that then later, you know, seed funding can crowd in order to fully flesh it out. How that develops and works, I don't know. But as things go at the moment, we use cloud infrastructure all the time. Most of the cloud infrastructure comes from the US oligopoly. We're going to use that. We don't have any UK cloud capability. But I think if we make a start, then we have the chance of doing it our way and doing it in a more democratized way than we'll get if we just leave it to the oligopoly in the US to run with it. Paul, I'm sure you've got views.
Yeah, no, I agree with everything you've just said, Dave. But I suppose in terms of purpose, I think there's a fundamental difference between the two. I mean, obviously, the hyperscalers have different visions of the metaverse, which are being kind of illuminated at the moment. But there is a common theme around harvesting data and revenue from customers, and whereas our vision is really, I think what we think is most exciting is about creating these immersive spaces for learning, for collaboration, for innovation, and for problem solving. And let's face it, as we talked about, as a nation, let alone as a planet, we are facing huge challenges and opportunities, which mean that we need those better tools. But we need ways to collaborate, as citizens. We need ways to get more diversity of thought and experience and contribution onto those hard problems. And we need to do that across national boundaries, wherever they may lie. And so I think this kind of bottom-up tooling up of, if you like, a species, is where we need to be headed. And of course, we're going to start with trying to do that as a nation, in terms of walking before we run. But really, that is the journey that I believe that we're on with this, and the great thing about these tools that we're talking about is that they can transcend, nation states and borders. And once again, as David said, it really is about this intersection of the cyber and the physical, whereas much of the focus of the metaverse is really just on the digital, which is a big part, but it's missing a trick.
I mean, that's excellent, Paul. Now, let's just pick up on this a little bit more.
Actually, Mark, I'm going to be cheeky. Oh. Can we turn the tables on you, actually, because you were very involved in the summit last July, and you're the chief scientist at Turing. You're a professor in data-centric engineering at Cambridge. I'm sure you have views on the cyber physical infrastructure that maybe we've not given you a chance to say. Is there anything you want to add, in this fireside chat about what you feel it means not only to academia but also to an institution like Turing?
So the cyber physical infrastructure, first of all, is absolutely essential for us as a nation to move from the artisanal type of activity that we're doing, where we create little bespoke solutions, or bespoke artisanal constructions of digital twins, scaling that to the industrial, to the national level, where we then have building blocks that can be reused, that can be deployed in a very agile way, and gives competitive advantage, is something that is crying out for this cyber physical infrastructure. So it's absolutely essential. And, you know, we can look back. David mentioned the telegraph, and, you know, we'd been talking the other day about Lord Kelvin standing, you know, in the mist one early morning when the first transatlantic cable was sent under the sea, and it didn't work first time. But you know, if we think about the development of software and the vast complexity of software, modularization of code, and the various you know, common interactions and so on, have been absolutely transformative and have allowed such complex software that controls you know, our lives. And so this modularity, this common language, this common set of tools is going to be absolutely essential. And certainly the Turing sees this as one of the grand challenges that we really need to focus on in being able to address some of the existential crises that not only the nation, but us as humanity actually face. So the ambition is huge and it's absolutely essential, but where, Paul, would you start?
Well, I'm not going to repeat what we said about the foundational elements. I think we've underscored that, and that is where we need to start. You know, this is what we would say is a kind of a horizontal earth shot, if you like. You know, it is a very big vision, but as David said in the presentation, you know, there are agile, tangible steps which would deliver value along the way. I suppose, you know, if I was to talk about, you know, we talked about lots of different potential use cases there, but if I was to talk a bit more about one of them, which is kind of near and dear to my heart and history, you know, of logistics, you know, at the moment, you know, moving to electric vehicles, you know, will help with pollution, you know, moving to autonomous vehicles will help the operators. But we're not really, with either of those, going to move the dial on things like, you know, congestion, you know, the quality of the services that customers enjoy, you know, how we make better use of our infrastructure and, you know, and stop everybody doing their own thing, which is kind of what's happening at the moment. And, you know, this is behind something that I often annoyed government with a few times, which is the concept of building an internet of freight for the UK. And what's at the heart of that is this idea of the kind of cyber physical platforms and smart services to do that orchestration, to do the business model transformation, to get sectors, but also competitors working with one another, giving them the tools to do that, and then using AI and digital twins to optimize how we move people and goods around many different media. So, you know, part of what we have to do in this process, and hopefully what the consultation will help with, is to identify, as well as the foundations, what could those MVPs that David referred to be, the kind of verticals, which we would use to both, if you like, test the foundations, work out where there may be things missing, but also start delivering some value across some verticals. David.
Yeah, I mean, for me, the really important thing is that you co-create the infrastructure. So we talked about the digital commons, for example, alongside some applications, some MVPs around. I mean, you mentioned Internet of Freight, but there are some great net zero ones out there that we could take a look at, which is really about monitoring what's going on and being able to act and see the effect of acting, using smart machines, you know, offshore energy, for example. So that's really important, and the reason that's important to do the co-creation is because otherwise you'll build the wrong thing into the infrastructure, into the core, let's call it middleware, even if you like, in the standards, and it won't faithfully give you the capabilities that you need, and you don't fully realize what that is until you actually start trying to build it around an application. So I think the two go hand in hand, and it's agile. The first attempts won't be quite right. There'll be things missing. From how do we handle time, for example? Which parts should be real time and which parts can be, you know, use data buffers to, you know, run things asynchronously. There's all those kind of things that we need to just work out and see what works. A real danger is that we stand up groups who work on some of this without really having the applications to hand. And so, like a group of philosophers sitting around a blackboard, they'll come up with something that's beautiful, but isn't actually usable.
Paul and David, I think this is probably a good point where we open up the Q&A to everyone that's attending. And I have to say, there's an avalanche of questions here, and they're all fantastic. So I was hoping to be a bit systematic in terms of how I was going to select some of the questions given the time we've got left. But I fear that might not quite work out. But just following on from what we've been discussing, there is one question which asks, what are the metrics that you want to track and hopefully achieve in the short and mid-term? Any comments, preliminary comments about that?
Well, can I just say that we will attempt not to answer offline as many of these questions as we can. So please don't feel that if you don't get them answered, you're not going to hear from us. We will do our best, not that we've got anything else to do. So in terms of metrics, you know, clearly at the end of the day, it's about adoption, and it's about those kind of impacts that, you know, I talked about in the presentation. I think we're gonna have to come up with new metrics, if you like, for a new infrastructure. But I think something that's close to my heart is, you know, how we get this being woven into, hopefully, you know, the way that government policy and strategy is enacted, the way our public services, you know, re-engineer themselves over time. And I think this is where, you know, it's very encouraging, not only that we've got, you know, ARIA kicking off, but also that what Patrick Vallance is doing with the Office for Science and Technology Strategy in order to kind of connect together, you know, government use of technology. And so I think this is coming at a great time from that. And so I would also be looking to hopefully to see, you know, what the level of adoption is, you know, within kind of government policy and strategy as well. David.
Yeah, first I'd like to thank Daniel Angelov for the question. Daniel, if you don't know, is a recent PhD graduate from the Edinburgh Centre for Robotics, who's over in the US at the moment doing a startup in AI. So I'm dead proud of the question, and I can see where it's coming from because he's being asked that and is doing his startup by his investors. My answer to it is it's really wrapped up with what are the first applications we're going to do. We really have to show tangible benefit in, you know, a timescale of a few years with some of these MVPs to get the idea across. So it's the extent to which you can make a hospital queue shorter, or, you know, you can have a realizable impact on net zero goals, that kind of thing. So those kind of, if you like, impact goals that we have to define that are wrapped around the particular applications. And then beyond that, it's just the extent to which we're starting to apply the principles and building in some of the functionality. It's not a tick box exercise, to quote the minister from his earlier consultation point, but we, you know, to what extent are we managing to include all those elements of, or some of those elements of ingredients and recipes in the architecture that we build?
There's a number of questions naturally about standards, of course. But there's one here that's quite relevant to the development of standards and then the subsequent adoption of them, which is talking about commercial sensitivities, liabilities, and concerns over IP rights, which act as barriers to collaboration between organizations. And you know, how do you see us overcoming these sorts of challenges to fit into the CPI vision?
I'll go first, if you like. I think this is part of the reason why it's important that government, you know, helps to fund the initial standards and that they're open, because that provides, if you like, an interface behind which you can keep your IP. So if you have some, you know, smart things, whatever they are, smart in the broadest sense, which have valuable and game-changing, then you don't have to really reveal the innards of that. That can still give you competitive advantage. But because you've got access to other modular units, which, shall we say, are generic, You don't have to reinvent them all in order to build a complete system. You can adopt the ones that are already out there, and therefore it reduces the friction of going from having your great idea to producing a system that provides utility to a customer, a product or a service. So I think there's still scope to maintain your IP and protect your IP, but it's an accelerant. It enables network effects. It means you don't have to reinvent the wheel.
And just to build on that, you know, I think one of the things that falls out of that we've spent quite a lot of time discussing is one of the other things that's missing is we're going to need some new delivery vehicles for creating those shared kind of pre-competitive building blocks, you know, because they need to be enterprise grade, you know, they need to be scalable, they need to be fit for purpose, you know, if we're going to build any kind of solutions on, but particularly if we're going to start building critical national infrastructure on top, but they also need to be secure, you know, and we have to get that balance right between security and, you know, open kind of innovation, and that's very central, you know, I'm thinking. And to do that, we're going to need some new delivery vehicles. This is not something that academia can produce. It's not something that the private sector can necessarily produce on its own, because they'll probably want to own it themselves. So the foundational kind of building blocks, you know, we've been talking about how those might be created by some new delivery vehicles built in the way that we would expect if they were coming out of a, you know, a cloud hyperscale or whatever, but with the idea that they can be put into public ownership, if you like, or made available for then this sort of crowdsourced innovation on top of those building blocks that David was just talking about to occur. So it's getting that kind of hybrid approach going, and that's, those new delivery vehicles are part of the kind of the ecosystem, if you like, for the CPI.
Let's have one final question. So we've really focused at the innovation end of the CPI, and there's one question here at the more technical, potentially theoretical end. So you asked me to chair this, so this is the danger of having an academic in control of the buttons. But are there any concerns around emergent behaviour? You know, we've got interconnected machine intelligence, cyber physical systems, could have unknown consequences as complexity increases. Will you sleep well tonight, Paul, David?
Yeah, I'll sleep well tonight because this is over. But apart from that, but apart from that, absolutely, I couldn't agree more. I mean, we're facing that already with the sort of, you know, GPT-3, and then the new one that came out, a 30 billion parameter net that was released 2 days ago, you know, on the web. And yeah, there are a big hall of mirrors inside them, and the biases and emergent behavior is what it's all about. Nobody can explain how it does what it does, but they just say what. So we're already facing that, and the issue about how do you regulate that. You know, certainly if do you remember all the stuff about chaos theory? You know, if a butterfly takes off in Panama, then you get a hurricane in Texas, and it's nonlinear systems. It's those initial conditions, change initial conditions, and you end up in a different place. Those are all things that we need to be aware of and to think of. But the only way we're going to find out is by building it.
Yeah.
So
my final comment just on that would be,
yeah,
you know, we cannot, as I often call it, play technological King Canute on this one. You know, this is going to happen, and there is an opportunity for the UK to lead and to partner with other countries, you know, on this. And we have to get our feet wet. But I completely agree with what David said. We have to do it with our eyes wide open, both in terms of the intended and the unintended consequences.
David, Paul, thank you very much for your vision. Thank you for your leadership. And for everyone else that has joined us today, we will be getting responses to all of the very thoughtful and stimulating questions, important questions out to you. And I think it only remains for me to say, have a good Friday and have a good weekend. You've got a lot of reading to do over the weekend. So,
and thank you, Mark.
Bye.
Thank you, Mark. Thank you, everybody.